Let's do problems 18 and 19. On problem 18, we're told about marks on a chemistry test that are distributed normal with a mean of 65 and a standard deviation of 12. So we write it like this. And the question is, find the probability that students have scores less than 50. So this translates into this problem. And what we want to do is a X type 1 problem means that we have to standardize X, and then using the Z score table we can solve the problem as though it was a Z type 1 problem. So standardizing this amount turns X into Z, and then 50 minus 65 divided by 12 is what we want to calculate. When you do that, you get P Z less than negative 1.25 standard deviations from the mean. Drawing that, what we want to find is the probability of being here below 1.25 standard deviations below the mean. Looking on the margins of the negative table for negative 1.25, and inside the table we see that the answer is 0.1056. That corresponds to the answer A, 11%. So let's do problem 19 now. Using the same information, what is the approximate 90th percentile of the mark distribution? So what score would a person have if they perform better than 90% of the rest? Given this percentage and ask for a mark or the variable value, this is a backward problem, and because it's about something other than a standard normal, it's called an X type 2 problem. Okay, so let's set this problem up with a diagram. So with a sketch, we'll divide it from the other one. With a sketch, I want to know where am I first in terms of standard deviations from the mean to have 90% on the left. And I'm going to put 4 decimal places so I remember to look inside and out. Right, so this is my first step. So looking inside the table, the best answer is at 0.8997. It's the closest we're going to get to 90%, and that is where Z is equal to 1.28. So at 1.28 standard deviations from the mean, there's 90% of the observations on the left. Well, what's the grade then for that? That's the second step, translating that into a grade or a mark. What's the grade is Z, standard deviations from the mean. Putting everything together, Z is 1.28. Standard deviations is 12. And the mean is 65. And you add all of that up, and you get the answer 80.36, which corresponds to answer A.